Hello, algebra kids. We're on the home stretch here, people. So let's stay in the game and let's get moving. So what is a rational expression? We're going to be simplifying rational expressions, so we need to understand what they are first. A rational expression is an algebraic expression whose numerator, which is the top, of course, and denominator, which is the bottom, are polynomials. I'm not sure if that page number is right or not, depends which book. Now let's go on with that for a minute. I don't expect that to totally make sense quite yet. The denominator can never be 0 because it would be undefined, right? We cannot divide by zeros. So any values that would make the denominator a 0 are called excluded values. So you will be asked to find excluded values. And when you are, you look directly in the denominator and say, what's going to make that 0? Because whatever the answer to that question is, that's your excluded value. A rational expression in its simplest form, when the numerator and denominator have no common factor except 1. That's when you know you're done. When there's nothing in the top and the bottom that can be simplified any further. There's nothing you can divide or cross off or cancel in either. All right, so let's practice, because we know there's different times when we can simplify things super easy and other times when it's more difficult. But first, let's start with this. Excluded values. And what did I just say? What part do we look at when we're trying to find excluded values? That's right, we look at the bottom. So I'm going to focus in on the denominator whenever I'm asked to come up with excluded values. And I'm going to say, well, what's going to make that 0? Because I cannot have that. It's undefined. So, I mean, that's simple enough to figure out in your head. But if it was something more complicated, the idea is the same. You set it equal to 0. And you solve it. Sometimes the solving is easy, and sometimes it is hard. In this case, it was quite easy. Our excluded value is -4. So in other words, we could put anything in for g here, but we cannot put in -4. That's not an option. All right. Now again, we're going to look in the bottom. But now that's a little more tricky, isn't it? But we still do the same concept. We still set it equal to 0. And now we're going to go back a little bit here and think, okay, we know how to factor. We know the first thing we learned was greatest common factor. And that was when we looked to see if there was anything the same in both of them. And there is. What is it? There's an x. So I'm going to factor out an x. I still will have 2 terms inside, same number of terms, and it is still equal to 0. So if I divide an x out and take 1 out here, how many are left? 1. And if I divide the x out of here, what's left? Just the 15, because I've taken the x out front. Now we're going to the zero properties rule that says if this is multiplied by this, one of the two is going to have to be 0 for this to be a true statement. So either this is equal to 0 or this is equal to 0. So then this is done. Okay? But this one we still have to solve. There are 2 excluded values there. If you put a 0 in here, we get 0 minus 0. That's 0. If we put a 15 in here, we get 15 squared, which is 225, minus 15 times 15, which is 225. And what do you end up with? 0. So that's why both of these are excluded values. Make that a little clearer. All right, then we get to the quadratic looking equation, the trinomial. But again, we're looking in the bottom. And now that it's 3 of them, and you notice the order, a y squared, a y, and a number, we want to see if we can factor. And we want to see if we can think of two numbers that add to give you the 5, multiply to give you the 4, because it's just a 1 here, so it's a pretty straightforward one. And they're both positive, so it makes it even easier. And the answer would be 1 and 4. So I can now break that down into y plus 1 times y plus 4 is equal to, what did I say to set the bottom equal to? 0. There's that 0 property rule. One of these that are multiplied together have to be 0. Either this has to be 0 or this has to be 0. And some of you are getting very good at doing that in your head, which is just fine. It's either going to be -1 or -4. If I put in either of those values here, you will get 0. And we can't have that. Okay, so there's two answers for that one as well. All right, so that's excluded value. So I would just kind of block that out. So when you get to excluded value problems, you're going to want to refer back to that. Now the rest of this is simplifying. So simplify each rational expression if possible. So maybe sometimes you can't. And identify any excluded value. So we got two things to do. And I'm going to underline them so I don't forget. Got to simplify and we got to identify. Okay, first thing you look at is, do I have just all multiplication on the top and bottom, or am I adding and subtracting? Okay. No adding or subtracting. So that means it's actually easier to simplify. So first thing you can do is look at the numbers. How does 2 over 14 reduce? You can divide by 2 on both of them, can't you? So you would get 1 over 7. And then do you remember how R4 is? We got 4 R's on the top and we have 1 R on the bottom. Remember, it's like we could write it like this, but that's just kind of tedious, isn't it? You can put the 4 R's on the top and the 1 R on the bottom and know that one pair of them crosses off. And how many are we left with? 3. But that's really what we're doing. We're subtracting them. 4 minus the 1 is 3. All right, so we have that for our answer, and you don't need the 1, just r to the 3rd over 7. That is the simplified. Then it says identify any excluded values. So we look at the bottom. 14r equals 0. Divide by 14. R cannot be 0, and that's how you can write that. Oopsie. Is r cannot be 0. So actually up here, it would have been wiser for me to say x cannot be 0. Cannot be, put the line through them, because those are excluded. Those are the things we do not want. All right, let's try the next one. Okay, again, look at it. Look at the top and bottom. Are we dealing with multiplication, addition, subtraction, what? And we can say, well, we got multiplication, 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 but then we got these additions in there. So we can't just start picking, class. Hear me and hear me loud. I cannot just do 6 divided by 2 is 3. Can't do it. Okay, when there's addition, you have to be able to cross off a factor that is multiplied by the whole thing. Let me show you what I mean. When you look at this top part right here, I have to see if there's anything I can factor out of it first. Do you see anything in common there? How about the 3 and the 6? Do you see a greatest common factor here? Yeah, the 3. And how many n's can we take out? If this has 2 and this has 1, can take out the lowest amount. Just rewriting this. Okay, so I took out a 3. If I divide that by 3, what's left here? So this is review. We've done this. 2, and I took out 1 n. So how many are left? 1. Oh, I took out the whole 3n. What do I put? That's right, a 1. So now I'm going to rewrite the bottom, and I want you to notice something now. This is different than this because I have 3n times this whole thing. It was in parentheses. And then I've got this whole thing in the bottom. I can't split this up and cross off part of it, but I could cross off the whole thing if it was multiplied up here, and it is. So I am going to cross off my 2n plus 1, and I am left with just 3n. Isn't that fun? I love doing these. Okay, now we got to do excluded value. So again, we focus on the bottom, set it equal to 0, and solve. Oh, there goes the cuckoo clock. And cannot be negative 1/2. That was just simple solving. I subtracted 1 from both sides, and then I divided by 2. All right, let's look over here. Okay, I only have one term up here, so there's nothing I can do there. See, here I had 2 terms, so I could look at factoring stuff out. Can't do anything there. Let's look in the bottom. Got 2 terms, so I'm going to look and say, is there anything I can factor out of those? 3p minus 2. No. I can't simplify this. This is one of those if possible. I can't. You cannot cross these 2 off because of it's this minus this. These go together. Okay, you can't split those. Just like this went together over here. And this went together until I factored out, and then I brought in the multiplication. So this is it. I'm going to box it. That's my answer. For simplifying, now I need to find the excluded number, so I take the bottom and I set it equal to 0. Add 2 to both sides. Divide by 3. And p cannot be, whoopsie, I'm so sorry, 2/3. All right, let's take a look at the next page. A lot of practice here so you can start seeing the pattern. Okay, so let's look at the top one here. Again, we're looking at this and we're saying, okay, adding, there's adding. Okay, so I don't see anything. This has to stay together, x plus 2. So unless I get an x plus 2 somehow factored out down here, I can't cancel anything out. And right now there's nothing, but it is a trinomial. So we can try. Is there something plus something that's equal to 5 and something times something equal to 6? And the answer is yes. 1 times 6. Wait a minute. Did I do that right? 1. Wait a minute. I'm doing something wrong. Yeah, 1 and 5 is not going to work. I was going to do 1 and 5. I'm like, But we could do 2 and 3. Will that work? Yeah, that will work. Okay. Little brain snafu there. So these we're not using, but we're using 2 and 3. And now, see, things are different, class, because they're multiplied by each other. So I can take this whole thing now and cross it off with the whole thing on top. I just can't bring out parts. So this is gone, and you guys need to tell me what is left on the top. Because I only have x plus 3 on the bottom. That's right, a 1. It's never nothing. There's always something there. All right, let's look at B. They slowly get a little more difficult. I'm wondering who can notice the pattern here. That's a difference of 2 perfect squares. That's right. So that can be broken down into w plus 2 and w minus 2. Oh, good, because now we got the multiplication. So if I can get either one of these on the bottom, we can cancel them. Let's try this. What plus what equals a negative 8? And what times what equals 12? 1 and 8. I'm sorry, thinking of factors of this. 1 and 12. No. 2 and 6. Oh, 2 and 6 might work. It's got to be positive, and it's got to be negative. So negative 2 and negative 6. Double check. Does that work? Does. Yay. So we have, I'm going to write it over here, w minus 2 and w minus 6. Yay! Do you guys see it? Now we can cross those off. Once you get the hang of this, it's actually really fun to break these down and cross things off, and out they go. All right, let's look at this one. All right, so the top is, again, two things. We want to look and say, is there a greatest common factor? The answer is yes, 5. If you divide this by 5, you're left with an x. If you divide this by 5, you're left with a 2. Okay, now this is sort of similar, isn't it? Wouldn't we like it better if it was x squared minus 4? And I would say, yes, we would. And who remembers how we can get these to switch? You can rewrite this. Pulling out a negative, it switches the sign of both. Then we are like, oh, good, because I got my x first up here, so I'm most likely going to want my x first down here. So I've got x squared minus 4, and that is, again, a difference of, same thing we just had right here. Difference of 2 squares, exactly the same, except we got the 1 out front. X minus 2 and x plus 2. Now everything's multiplied except for inside. So again, as a whole, we can cross that off and that off. And I'm left with a, let's see here, a 5 on the top and a negative x plus 2. You can put the 1 if you want. You don't have to. You can put the negative in front of it. There just can only be one negative. All right, D. Top, looking at the top, I see them again in that other order. So I'm gonna get that r first by taking out a negative 1, so that we have it in descending order. And now I can see we can take out a 6 as well, can't we? So we're going to take out a negative 6, and we'll have r minus 3 left. I divided a 6 out of both of them. Oh, before I try to factor here, I see we can take a 2 out. So I'm going to do that and make it simpler. Divide a 2 by all of these, and I will get that. So negative 6 times r minus 3 all over 2. And I'm going to halt there for a minute because now I'm going to go ahead and see if we can factor that. 2 numbers that add to give you 4 and multiply to give you a negative 21. So factors of 21, I immediately think of 3, 7, and that is a difference of 4. So it must be somehow here. 3 and 7. But one of them's got to be negative, but that has to be positive. Okay. Does that work? If you're not sure, try it. Check it out, and then switch it if it doesn't work. So that's gone. Got r minus 3 and r plus 7. Yay! They're all multiplied again, and here they are in parentheses. Yay! Goodbye. Adios. Okay, there's something else we can do. 6 and 2. That's also multiplied, isn't it? They're not being added. They're being multiplied. Divide by 2, and we end up with a negative 3 on the top and an r plus 7 on the bottom. And the negative can be in the front. It can be out here. All right. Let's keep moving. If you are St. Agnes kiddos, you probably can stop at this point. I don't believe there's going to be any problems like example 5. If you are St. Peter's kids, then you keep trucking. All right? Okay. So, a theater at an amusement park is shaped like a sphere. The sphere is held up with support rods. What is the ratio of the theater's volume to its surface area? Okay, ratio. Ratio is a fraction. They want volume to surface area. They want the ratio. So what I'm going to do is I'm going to take their formulas and put them in place. So I'm going to take the volume formula and I'm going to put it up here. And I'm going to take the surface area formula and I'm going to put it down there. And now we are going to learn how to simplify this. Okay? What's the first thing you see? Good. It's all multiplying. That's right. So we don't have to worry too much about that adding and getting them, moving things properly and crossing up them in chunks. Everything's multiplied, so we can just kind of crisscross applesauce. All right, the pies are gone. I got 3 r's up here and 2 down here. So how many do I have left and where? That's right, 3 minus 2 is 1, so now I have just the 1 up there, r to the 1. So all I have to deal with is these numbers. And I'm just going to show you that that's like a double-decker fraction. And how would we get rid of this 4 over 1? Because that's in the bottom. I want to get that out of there. That's right. Multiply by the reciprocal on the bottom and the top. Because 4 over 1 over 4 over 1 is 1. So I'm not changing it. I'm changing the way it looks. Wait, did I do that right? The heck am I doing, class? See, you're not here to correct me. 1 over 4 and 1 over 4. Does that look better? Thank you. I could hear you. I could hear you guys right through the video. Amazing how that works. All right, so those cancel off. The 4s cancel off. And what are we left with? 1/3 r. Everything else is gone. Fun. All right, last problem. Use this ratio now to find the ratio of the theater's volume to its surface area when the radius is 45 feet. Well, we just found this. This is the ratio of the volume to the surface area. So if we know the r, we've got it. So we're going to put the r in. And you know, because it's a ratio up here, I really should have, I'm seeing that now that I just circled ratio, I wish I would have left the r there. That is a better way of writing that answer. It's the same answer, but that's written as a ratio, isn't it, class? And you're probably were yelling at me about that too, because you guys are so good at keeping me on my toes. Now the ratio is radius over 3, and the radius is 45. Boom. All done. Have a great day. God bless.